Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. The topic of this lecture, the leftover important questions of differentiation of P1. For this lecture, I am using the work of one of my best students, Ms. Sharika of class 2021 in the Lyceum. An important advice for me and for everyone, we should be nice to others. This is an important question in differentiation. Stationary value of y and stationary value of dy upon dx. First, we will understand this concept with respect to y, stationary value of y. So, to get the stationary value of y, you should differentiate y. Get its differential. The differential of y is dy upon dx, which is 2x minus 16. Equate this differential to 0, get the x coordinate. Substitute x into equation of this y, jo bhi, whatever, and get the stationary value. So to get the stationary value of this function, you need to differentiate this, equate this quantity to 0, get the x coordinate, substitute x coordinate back into original equation and get the stationary value. What if you need the stationary value of this quantity? For that, you need to differentiate this quantity. Equate this second derivative to 0, get the x coordinate, substitute x coordinate back into this equation, original equation, and get the stationary value. This is the way to get the stationary value of any quantity. What if we need nature of this stationary value? For that, you need to get the second differential. You need to differentiate this again. So you need to observe the sign of second differential at this particular value of x. So it's positive. So minimum value, this value is minimum. What if I ask you find the nature of this stationary value? For that, you need to get the third differential. This is the third differential. And observe its sign at x8, this particular value of x. It's positive, so this value is minimum. This concept is very important. Make sure you understand this concept well. I will use this concept in this question. In the second part. Well, the first part is of integration. If you have done integration, you can do this part yourself. You need equation of curve. For that, you need to integrate this equation. When you will integrate this equation, you'll get this thing. Let me do one correction. This is y and this is dx. Well, when you will integrate this, you will get this thing. And with the help of this point, you can get the value of c. And this is the equation of the curve. You can do this when you have done integration. If you have done integration, you can do yourself. And you can understand this solution. Now, second part, I'm interested in second part. Show that this part is of this concept. Show that the gradient, meaning dy upon dx, has a minimum value at x2 and state this minimum value. Since they ask, we have to show this gradient has minimum value at x2. For that, we need to first we need to differentiate this, or we need to get the second derivative. And we need to equate second derivative to 0 to get the x coordinate of the stationary point. The x coordinate of the stationary point is 2. To check whether this point is minimum, whether this value of x is minimum or maximum, you need to get the third derivative. This is the third derivative, the differential of this quantity. Now you need to observe this third derivative at this particular value of x. The sign of this third derivative at this particular value of x is positive, so this gradient has minimum value at x2, we have shown. Now the question is state this minimum value. For that, you need to put this x2 over here, and this is the minimum value. If you want to take the screenshot of these two pages, you can. Well, this question is simple. You can do this question yourself. I'm going to take the leftover questions. This question is also simple, so I'm leaving this. Now this question 29. This question is important, especially this part. This part. Question 29. The inside lane of a school running track consists of two straight sections, each of length x meters, and two semicircular sections, each of radius r meters, as shown in the diagram. These straight sections are perpendicular to the diameter. We have to show this thing. Well, let me make few changes. Let me add this line here, this here, this is r, this is 2r. So we have one rectangle and one circle. Show that area means area of one circle and this rectangle. But before that, we need to use this length and we need to make r subject. So for that, we need the perimeter. So this is x, and this will make 2 pi r. So this is the perimeter of this diagram. First make r subject, and then for area use this formula. Area of rectangle, it should be 2rx, and area of circle. Here we have shown this. Oh, sorry, we need to make x subject because in area formula we have r. So this is not right. We need to make x subject. This step is right, and after this step do this. And then substitute x here. Now the last part is show that when a has a stationary value, there are no straight sections. Straight sections means x. It says there are no straight sections. That means you have to show that is x is 0. You have to show this thing. So first you need to differentiate this and get the value of r. So when you will substitute r over here, you must get 0. Let me do this thing. And try to substitute the exact value of r. The exact value of r is 200 upon pi. Now substitute this value over here. 200 pi, 200 upon pi. The answer is 0. Shown. This is what we had to show. No straight sections. Determine whether this value is maximum or minimum. For that you need to differentiate this here. The answer is negative at this value of r. So this quantity is maximum. You can take the screenshot of the solution of this question if you want. This question is also important. In this question, we have to show the area of this rectangle. The area of this rectangle will be x times y. So the area of rectangle is xy, but the problem is we don't have y. You can easily get y if you find the equation of this line. So get the equation of this line and this make y subject from this equation Now substitute y here. So the first part of this question is important, and the important part is this: get the equation of the line. Second part is simple: find the stationary value, differentiate this, and for nature get the second derivative. For stationary value, equate gradient to 0, get x8, and then substitute x here for the value of a. This is the answer, the stationary value. And for nature, get the second derivative. It's negative at this value of x, so maximum. This quantity is maximum. You can take the screenshot of this question as well, the solution of this question if you want. This question is simple, I'm leaving this. This one is also simple. I'm leaving these easy questions. I have done a question of this type before. This question is of integration. If you want to take this screenshot, you can, because I already have done a question of this type. You have to integrate the second derivative twice. I'm interested only in the first part. The base of a cuboid is this, and the volume is this. So use volume equation of volume, and get, in fact, the formula of volume, and get H subject. Get H. Make H the subject by using this volume. And total surface area, this is simple. It's a closed cuboid. Total surface area of cuboid, it's not mentioned that whether it's open or closed, so you have to consider this as closed. So this is the area of closed cuboid. So this is the answer, and you make sure you write A. Don't write surface area as SA, just write A. Or you can do this later. You can write this here. Surface area is A. Since surface area is denoted by A, therefore we have shown. Second part is simple. Stationary value and nature. You all know how to do this. You can take the screenshot of the solution if you want. We have done a lot of questions of this type. This question is also very simple. I'm leaving this. I'm just interested in the leftover important questions. Question 38, first part. The first part of this question is, in the case where the curve has no stationary point, show that a square less than 3b. No stationary point means no real roots, means b square minus 4ac less than 0. This is the equation of gradient. You need to use b square minus 4ac less than 0 onto this equation. We have shown. Find the set of values. Y is a decreasing function. Decreasing function means gradient is negative. Decreasing function means the differential is negative. This is the solution of the second part. The important thing is this: use dy upon dx less than 0, because for decreasing function gradient is negative. This question is simple. This question is important. 41, the first part. Express area of triangle in terms of P. Now this is the base of the triangle P plus 2. The most important part of this question is the coordinates of Q. Make sure you write the coordinates of Q correctly. Let me write the coordinates of Q correctly. So the coordinates of Q will be x comma y. And since x is P here, so you can write P comma Y. And Y, what is Y? You know, Y is the point of intersection of this curve and this line and this line. And this line has equation P. So when you will solve these two simultaneously, this one and this one, you can easily get the Y coordinate of Q. You just need to put P here. So when you will put P here, you'll get 2P square. This is the way to get the coordinates of Q, and this is the important part of this question, because this 2P square will become the height of this triangle. It's here. So the height of triangle is 2P square, and the base is P plus 2, it's here. This is negative 2, although this is negative 2, but you know distance is positive, so this is P and this is 2, so P plus 2. This is the area. And the second part is simple, it's rate of change. We have the rate of change of x, we need the rate of change of area. So this is the chain rule. You need to substitute dA upon dx from here. This is dA upon dx, dx upon dt is given, that's the answer. You can take the screenshot of the solution of this question if you want. This question is important, especially the first part. This question is simple, so I'm leaving this. The differentiation of this question is important now. Make sure you differentiate the function correctly. So first bring both in numerator and then differentiate them. This means f prime x, the differential. I state with a reason whether f is an increasing or decreasing or neither. So for increasing function, you know, f is positive, for decreasing f is negative, for neither means f0. Since this function is negative, you can observe this here thing, 1 upon x plus 1 whole square, 2 upon x plus 1 cube. So since this function is negative because of this negative sign, therefore f is a decreasing function. The next part, find the coordinates of the turning point. This is so simple. The same function is here, so we have the gradient is here. You just equate gradient to 0, get the x coordinate, and then get the y coordinate. You can take the screenshot. Now, simple questions, I'm leaving this. This question is important. 46. Well, we have this prism, and this is the cross section of this prism, this thing. This is 30, so this angle will also be 30 because of corresponding angles. This one is also 30. So you need to consider this triangle. This triangle is here. Okay, let me read this question. Shows an open, diagram 1 shows an open tank in the shape of a triangular prism. The vertical ends are isosceles triangles. And the length of AD is 40, which is the height of the prism. The tank is fixed, water is poured at a constant rate. That means centimeter cube per second means the rate of change of volume. The depth of water t second after filling is h. Show that the depth of water in the tank is h. Show that when the depth of water is h, volume is this. So this is simple. We just need to use this triangle here, and this height, this is h, and you can suppose this as x. So basically I'm working for this length, the base area. I consider this triangle in order to get the area of this triangle, the shaded part. So this length is x, this length is x, so this length is also x, so the total will be 2x. So first get x by using tan theta in this triangle. X is this. Now get 2x. Now the formula of volume is base area into height. Now get the area of this triangle. This is 2x, height is h, so you can easily get the area of this triangle. This one, this triangle is here. I can label this as M, N, so this is E, M, and N. So the area of this triangle will be half base into height. It's here. And the height is 40 of the prism. So this is the base area, the area of this triangle, and this is the volume. This first part was important. Second part is simple, it's chain rule. Sorry, so use this chain rule and get the answer. This quantity is given, dV upon dt is 200. Get dV upon dH by differentiating this, and this is the answer. Take the screenshot of this question because this question is important. I'm sorry. Next question is again twice. You have to integrate this twice. So I'm leaving this. I already have done a question of this type. You can take the screenshot of the solution of this question if you want. This question is important in integration. And I already have done a question of this type in this lecture, in the previous lecture, I guess. This question is also simple, so I'm leaving this. 49, important question. The first part is important. A farmer divides a rectangular piece of land into 8 equal size rectangles. These are 8 rectangles. Each sheep pen measures x by y and is fully enclosed by metal fencing. The farmer uses 480. So use perimeter. So count x. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12x. Count y. There are 8 vertical lines or 10 vertical lines. 1, 2, 3, 4, 5. So there are 10 vertical lines. So perimeter will be 12x plus 10y to 480 equals to 480. Get y subject and then get the area of this rectangular garden fencing. So area will be 4x times 2y. And this is the area. Second part is simple. Given that x and y can vary, the dimension of sheep for the area is maximum. So we need dimensions. Dimensions means x and y. So first equate gradient to 0, get x and then get y, and write dimensions in this way. This is the proper way. X meters by y meters. So x is 20, I guess. Yeah, 20 meter by 1, let me check y, 1880 meters. In meters. Yeah, this is in meters. Well, this chapter is over. I have discussed all the important questions, alhamdulillah, of this chapter, and I hope these lectures will help you all to understand the solutions of the important questions of differentiation well. Now, this is the advice for me and for everyone. Be honest. And be well mannered. We should be honest and we should be well mannered. Allah Hafiz.